All right, Lieven, maybe we should get started.
Okay, thank you, Dirk. Thank you for hosting ProcessVue in this Tech Talk. We're going to talk today about alarm management KPIs and how important they are for the overall efficiency and effectiveness of the plans of your customers. ProcessVue is a software suite for alarm management. It's a culmination of 30 years of experience and expertise in managing alarm systems and capturing alarms and events from different DCS and SCADA systems. ProcessVue is trusted by leading industry organizations over the world because of its rich functionality, ease of use, but also because of the knowledge, support, and the passion of the ProcessVue team. ProcessVue is also recognized by ARC as the preferred alarm analysis tool in the power industry. I am Lieven Dubois. I'm a voting member of the ANSI ISA 18.2 standard committee. I have been a contributor to technical report 4 of that standard, which is about advanced alarm management and handling. And I'm the elected co-chair of working group 8, working on technical report 8. That we hope to come out in next year, which is about everything that is not meeting the criteria of an alarm. My experience in alarm management goes back to the 1990s of the past century, where I was one of the first to introduce artificial intelligence to the subject of alarm management. During this webinar, I hope you will learn what are the alarm system performance KPIs, where you need to calculate them, how ProcessVue supplies them in reports and in dashboards, also how ProcessVue integrates with AVEVA software products, and how users have to improve their efficiency to better alarm management. From a practical point of view, like Dirk already mentioned, there will be a question and answer session at the end of the presentation. You can already post your questions in the chat box. We will go over these questions during the Q&A session. Okay. What are these alarm system performance KPIs? They are a set of values that serve as a benchmark to verify how well or bad the alarm system is performing. The performance of the alarm system has little to do with how the operators use it, but everything with how it is conceived, engineered, and configured. Typically, an alarm that is annunciated requires an action from the operator. And also, if the plant wants to comply with the standard, the definition from the standard applies. Each annunciated alarm requires a timely action. The purpose of a properly designed and engineered alarm system will allow the operator to have sufficient time to perform all the tasks he needs to perform in order to avoid the unwanted abnormal situation, the process deviation, or equipment malfunction, or to mitigate the effects from the abnormal situation that is occurring. If you want to know more about the timeliness of alarms, there's a webinar on the ProcessVue YouTube channel on that subject. A poorly conceived or engineered alarm system will typically generate too many alarms, most likely with the wrong priorities, and it will overload or stress the operators using it. And you don't want stressed operators when dealing with abnormal situations that they need to handle. So where do these KPIs come from? After the explosion at Milford Haven, the refinery in Wales, the Pembroke refinery in the UK in the 1990s, there was an investigation by the Health and Safety Executive. And as part of the investigation, there was found that there were too many alarms when the FCCU bursted. But also, they performed a nationwide survey to hear, by interviewing operators, what alarm rates were acceptable at the time. And what they found is that more than one alarm per minute is very likely to be unacceptable. 1 per 2 minutes is likely to be over-demanding. 1 per 5 minutes is manageable, and less than 1 per 10 minutes is very likely to be acceptable. And the result of these interviews were published in the EEMUA 191 guideline, which was the first guideline on alarm management and alarm systems, which was published in 1999. The KPIs still remain in the third edition, which was published in 2013. The ISA committee, who started as early as 2006, they have taken these KPIs and published them in the standard of 2009. The IEC committee took the ISA standard and published standard 62682 in 2015, where the same KPIs as almost the same KPIs as the one from ISA figure. The ISA committee then reviewed the content of the standard, and we published new KPIs in 2016, which we will discuss during this webinar. And to come is probably probably this year, the new IEC standard 62682, well, the revised or updated standard from IEC. So what are these EEMUA performance metrics? Well, this is a famous graph. You will find it in many alarm system presentations. But basically, it gives an overall view on the performance of the alarm system. It has three axes. On the left-hand side, you find the average alarm rates per 10 minutes. On the horizontal axis at the bottom, you find the maximum alarm rates expressed in number of alarms per 10 minutes. And on the top axis, you find the percentage that your alarm system is performing outside the target. And this gives you an overall view on how your alarm system is performing. The ISA 18.2 KPIs are similar. Basically, here you can find the same KPIs that EEMUA has published, but you find also KPIs on what we call bad actors. And what these bad actors are, I will explain later on in this webinar. So, the customer alarm system KPIs are not always the same as the KPIs from the standards. That's because different reasons. The standards allows you to define your own KPI in the alarm philosophy. And there are ways to do that. The reasons are, if you have a poor performance, and poor performance you can anywhere, jumping to the proposed KPIs would be sometimes a too great effort. So you can take it step by step, year by year, on condition that the KPIs are included in and motivated in the alarm philosophy of the plant. I mean, if you have one alarm per minute, going to one alarm per 10 minutes might be a too big jump. It's like the International Olympic Committee would say, well, only people who run fast, the 100 meters, sprint faster than 9 seconds can participate. Well, nobody would show up, right? So, yes, poor performance and making a plan to go forward can motivate why you have different KPIs in your alarm philosophy. What you also find, and that's very often in other industries that are not working 24/7, because the standard has been written for operators that are manned 24 hours per day, 7 days per week. You might need different KPIs. If you're only operating 5 days a week, then you might need other KPIs for different modes of operation, night shifts, weekend shifts, and day shifts. Or, and that's what we also have encountered, alarm management is a journey that does not stop when you have achieved the proposed KPIs. You can further improve. To my knowledge, Shell Downstream has set a target of 1 alarm per 30 minutes in the refineries. BASF is down to 1 alarm per 20 minutes in most of the plants. And Heineken has set a target of 1 alarm per week in unmanned shifts. So a good alarm system reporting and assessment tool should not only compare the KPIs to what is recommended by standards and guidelines, but also to the KPIs that the customer has defined in the current version of his alarm clock. If you want to learn more about KPIs, then you can go to the ProcessVue channel on YouTube and you'll find a webinar on this subject. So why are alarm system KPIs important? Alarms are set to inform the operator of abnormal situations, process deviations, and equipment failures that could impact the overall efficiency of the plant or the infrastructure the operator is monitoring. Remember that alarms fall out in two categories. You have remediation alarms. These are alarms to prevent bad things from happening, to prevent these abnormal situations. And you have also mitigation alarms that come after something happened to mitigate or to limit the effects of these bad events that have happened. Alarms do require operator action. An alarm without any need for operator action is, by definition of the standards, not an alarm. By consequence, alarm system monitoring assessment will inform plant management when things were likely to go wrong or went wrong, where things were likely to go wrong or went wrong, and how often this has happened over the monitored period. In hazardous industries, typically nuclear, oil and gas, toxic chemicals, engineers have built-in safety systems and safety functions and even automatic emergency shutdown systems that will kick in when the operator was unable to prevent the abnormal situation, the process deviation, or the equipment failure. In non-hazardous industries, like in food and beverage, some power plants, also pharmaceutical, an alarm that is not responded to often results in production loss, quality degradation, waste, and the economical impact or marketing impact of that can be even bigger. Recently, we had some chocolate producers in Belgium who had contaminated product in the market and had to recall these products from the shelves, which is of course very bad for market image. That damage is even bigger than OEE damage. So for plant management, alarm system monitoring will provide them a way or indication when, where, and how often things were about to go wrong, went wrong, what equipment, what areas were involved, and if the operator was able to correct or mitigate the situation. So proper alarm system monitoring assessment can help plant management in OPEX. Good alarm system performance means the plant runs smoothly and swiftly, and also in capital expenditure. The alarm system could inform the plant management where to invest and to get the plant run smoothly and swiftly. I was at a dairy plant in the Middle East, and they had just replaced all the valves in the plant. And we showed them the alarm system and performance monitoring software, and they said, whoa, we should have had this installed before we changed the valves. And we could have measured how much better we are doing today. Well, that's one of the reasons to install a alarm system monitoring and assessment tool. So what do you need to calculate alarm KPIs? Establishing a top 10 of the most frequent occurring alarms is easy. Any experienced spreadsheet user can make a top 10, top 20 of the most frequent alarms. The information can be found in the alarm and event historian, and you can export it to a spreadsheet, and you have functions like counting some of the values, and then you know how bad or what the most frequent alarms are. But simple top 10 is not part of the requested KPIs, as we just explained. So your customers need specialized software to match the activation of the alarm, the acknowledgement of the alarm, and the return to normal, the deactivation of the alarm. Without this analysis, no bad actor KPIs can be derived. And you need this linkage to be informed on capturing alarms, fleeting alarms, stale alarms. And typically, this linkage is typically what ProcessVue sequence of event service does for you. So what does ProcessVue do else for you? It monitors in real time the activation, acknowledgement, and deactivation of alarms. It analyzes occurrences in a chosen time slice. By default, it's set to 10, but a user can change it to 20 minutes, 30 minutes, 5 minutes, depending on how he operates his plant. It provides new real-time dashboards, which can be integrated in the OMI of the customer. It can generate reports at chosen frequency and distribute those reports by email to all stakeholders. The time that somebody sits in front of a software product to generate reports versus automatic distribution of reports already justifies the purchase of software. The reports analysis contained in the reports are targeted to help customers improve the performance. So you have a software, it distributes reports, you can log into the software and you can dive deeper and analyze and even get information on how to improve the situation. It does all that according to chosen standard, for instance, the ISA standard or the EEMUA standard guideline, and the alarm philosophy of the customer. Consequently, nobody needs to sit in front of a screen to perform the analysis, which is the first step in digitalization. I recall a customer in the Netherlands, whereby the customer has permitted access to the alarm and event historian, and people could download the information and make graphs with Excel. And as a result, in their alarm rationalization meetings, where they should be talking about improving the alarm system, they were talking about, why is your graph different from mine? What have you filtered out? What have you not taken into account? And by the time they got agreement on the figures, the meeting time was almost over. And the improvement almost did not happen. It went too slow, that process. Another good thing about automatic distribution of reports, nobody will forget to generate and distribute the reports. And a third benefit is that when you monitor online, you can specify in ProcessVue to call for action when certain action limits are violated, which is the second step in digitalization. So what are these alarm system KPIs that ProcessVue provides? In this webinar, I won't give a full demonstration of the ProcessVue capabilities, but in the next slides, I will try to demonstrate that the KPIs of IEC and ISA are available from ProcessVue. By the right-hand side of each line here, you find the reference to the clause of the ISA and the IEC standard. So we will talk about target alarm, average alarm rate per chosen or 10-minute slice, peak alarm rates per operator console, violations of maximum manageable time slices, which are called also alarm floods, frequently occurring alarms, chattering and fleeting alarms, stale alarms, annunciated alarm priority distribution, and the EEMUA performance graph. Well, let's go take a deeper look at the average alarm rate. At the bottom here of this table, you find the EEMUA proposed annunciated alarms per 10 minutes per operator console, which has a target of 1 alarm on average per 10 minutes and a maximum manageable at 2 alarms per 10 minutes. Now, by the time that the standard was written, a lot of software alarm management monitoring software was not able to do this analysis per 10 minutes. And so if there are no tools that can do this, there was an agreement to also allow annunciated alarms per hour per operator console, which is, if you expand this, extrapolate this, 1 alarm per 10 minutes, it would be 6 alarms on average per hour, which is of course a bit of a worry, because all 6 alarms can be annunciated in 10 minutes, which means that the operator has to perform 6 tasks simultaneously. I don't know of any human being capable of doing that. Would you be able to respond to 6 emails simultaneously and within a time frame of, say, 10 minutes? I don't think so. And that's the entire purpose of alarm management and alarm system monitoring, is to avoid this cognitive overload for operator. So Here is a screenshot from ProcessVue where you see these alarm rates. At the left-hand side, you can choose a site and areas of a site if you like. You can choose on the calendar a time period, and you can choose a set of KPIs from that list. What you see here is the alarm rate of a plant that was monitored, and you see at the left-hand side of this graph lower purple bars, and on the right-hand side higher purple bars. And if you look a bit in detail, you see that most of these bars are purple because they're in priority 2, and you see a black dashed line, which is the KPI that the standard proposes, meaning 6 alarms on average per hour. And you see that this is way over, well, actually on the right-hand side, the alarm system is flooding almost all the time. So if you receive such a report in your email box, you might want to log into the software and go deeper into detail. And you select on the left pane, you select the detail part of the time, and then you see what's happening on the specific days. You see that well, every day the frequency is of the alarms, or the alarm rate is above the proposed target or objective. Peak alarm rates are another KPI that is proposed, and it defines basically an alarm flood. You can distinguish 2 values here: the time slice, which is 10 minutes, and you see the number of 10, which means that for this customer, and also according to standard, at that point the alarm system is flooding. The ProcessVue KPI immediately provides you with the result on the monitored period, so saying, well, this alarm system is flooding quite regularly when it's overloading the operator with tasks to do. You can dive into detail here, and then you see that actually a lot of days the alarm system is flooding. You can go even hour by hour to see where and when it was flooding. And even minute by minute on the graph below. Here is another KPI, the percentage of time the alarm system is flooding, meaning it adds a third dimension to this alarm flood KPI. In the previous KPI, the time period and maximum value were defined. Here it states what percentage of time the operator should be dealing in an alarm flood. Suppose you have a shift of 8 hours, meaning 8 times 60 minutes is 480 minutes, which means 48 periods of 10 minutes. 1% of that is 0.48, which means basically that 1 out of 2 operators could be dealing with an alarm flood. I think personally that is still too often. Alarm flood should not happen. But, well, it's a journey, right? ProcessVue provides you with nice graphs that show these alarm floods. If you see at the down axis, you see certain day. For instance, this day, there was just 1 alarm flood, but that lasted for 99% of the time. Here you have 12 alarm floods, which also contribute only 41% in flood condition. So that gives you a good view on that target. You can even go further down detail, and you will see that there was an alarm flood at this day from then to then, which lasted 2.5 hours, where 153 alarms were presented, which is far too much. Another KPI proposed by the standard is the percentage of contribution of the top 10 most frequent alarms to the overall alarm load, which should be less than 1% to 5% maximum, with action plans to address deficiencies. So it's a little bit more complicated than a flat top 10. Typically, you provide people with a Pareto diagram, and you see here in this graph on the left-hand side the number of occurrences of an alarm. On the right-hand side, its contribution to the overall alarm load. And you see that the most frequent alarm is contributing 41% of the overall alarm load, which should be fixed. Now, why are alarms occurring so often? Well, that's because usually they are chattering. And chattering means repeating a number of times within a certain time frame, where the number of times it has to be bigger than 2. And you can define, or your customer can define, this number and this time frame in their alarm philosophy. Fleeting alarms, however, are alarms that are active for a short time, T, whereby T is defined in the alarm philosophy. So for ProcessVue, by default, an alarm occurring more than 2 times in 60 seconds, 1 minute, is considered as being chattering. And alarms that are not longer annunciated than 40 seconds, but are not recurring, are considered as fleeting. So what does the standard propose? Well, you should have 0 chattering and fleeting alarms. And if you have, you should have action plans to correct any that occur. Call for action, which I mentioned earlier. You have to remember that not all chattering alarms are fleeting and not all fleeting alarms are chattering. And we'll come back to this in the next slides. To enable the operator to get rid of chattering alarms, until the problem is solved at the source, the term and the function shelving is invented. Shelving means that an operator can put an alarm that is chattering on the shelf, so it's not annunciated anymore. So it's not disturbing him in his routine tasks. And usually the shelving is limited in time, for number of hours, and it has to be motivated by the operator in very many cases why he is shelving this alarm. That's because chattering alarms are not only annoying, but they can have multiple causes. And that's why we call for action plans to correct. Because what can cause chattering alarms is alarm limits too close to the operating point, or alarm limits within the operating window, bouncing instruments, transmission issues, badly tuned control loops, and what you all have. So you need to repair those. ProcessVue does a nice thing for you. It can distinguish the bad actors from the clean alarms. You see in the most frequent alarm here at the left-hand side, it's occurring more than 8,000 times. That is a bad actor. It's chattering all the time. However, the second most frequent alarm, only 50% of the time, it's matching the criteria for chattering or fleeting. And in the other 50%, it's still a valid alarm. Let's go. So what does this tell you? The top 10, well, if you want to dive deep, you can have a top 10 of, or top N of most frequent alarms, and you can view how long they're in. And as mentioned, this most frequent alarm has an average duration of 1 second. I mean, you cannot even read the text in 1 second. And the maximum duration was 2 seconds. It's just desensitizing the operator. Right. ProcessVue has a very nice feature. It has a feature that is a tool that helps the user, or the system integrator, or the engineer at site, to reduce chattering alarms. In this case, that we show here on the screen, putting a persistency time, usually an on-delay timer or a deadband. If you put on a persistency time of 30 seconds, that on that alarm, that would reduce the occurrence of that alarm with almost 99%. Now it's up to somebody to, of course, update the alarm logic and update the alarm documentation of that brand. As for fleeting alarms, these are very annoying. You see here, well, it's the same one. Of course, the most chattering one is also fleeting in this case, but you see others here that are also fleeting. They are in for 4 seconds, 6 seconds, 1.2 seconds, with a maximum duration of like a couple of seconds. So fleeting alarms desensitize the operator. What was that? What was annunciated? You have to get rid of those, and typically you can do this with putting some persistency timers in the alarm logic of that alarm. Let's go to another bad actor. Stale alarms. Stale alarms are defined in the standards as alarms that remain in the alarm list longer than T hours. In ProcessVue, by default, T is defined as 24 hours. And the standards propose that you should have less than 5 of these stale alarms present on any day, with action plans to address those situations. Stale alarms typically originate from state changes being annunciated as alarms of malfunctioning equipment waiting for repair, and or an alarm system that is unaware of the state change. If you put equipment out of service because it's broken, you should also take the alarm out of service. At a given customer site, stale alarms covered the entire alarm display as new arrives were added at the bottom of the list, meaning the operator had to first sort the list every time a new alarm was annunciated. An alarm philosophy allows the customer to set his own targets. Say a stale alarm is something that lasts for more than 8 hours, or more than 48 hours, or more than 72 hours, depending on the way he's operating. In this case, the target was set at 10, and there were 52 stale alarms out of target. Of course, if you dive into software, you can find the most stale alarm listed here. And if you dive even deeper, you can see here that these stale alarms are in there for more than 1,000 days. That's more than 3 years. So why are they still there? Nobody is doing anything about it. Another problem that we very often see in alarm systems is that people are always eager to put alarms in the highest priority. But what are priorities? Priorities are for the operator. Priorities allow an operator to give priority to situations with higher impact or greater urgency, meaning that most of the alarms should be in the lowest priority because they're just normal alarms and they should be dealt with. And this is what the standards propose. In a system with 3 priorities, 80% of those should be in low, 15% should be in medium, and 5% should be in high. Or if you have 4 priorities, then less than 1% should be in the highest priority. And actually, the EEMUA guideline specifies that you should not have more than 20 alarms configured in the alarm system at this highest priority, because then there's something wrong with how you have configured your alarm for your plant. I mean, highest priority means very often unsafe situations, and unsafe situations should be dealt with, not only for the health of the people working at the site, but also for environmental and regulating issues. So ProcessVue provides you with this ISA 18.2 KPI summary, and at the right bottom page you find this pie chart that tells you that in this alarm system they have configured most of the alarms in priority 2, 80%, which is not meeting the objectives of the guidelines and the standards. ProcessVue offers you also another view on this in bars, and you can also specify in ProcessVue your own internal targets, because if you have more than half of your alarms configured in the highest priority, moving them to the lowest priority will require some rationalization efforts, and you might not be able to do this in 1 year. So you might say, okay, we have 50% of our alarms in the highest priority. Let's make an objective to move them in reality, so with all the engineering work involved, to the lowest priority, and we will have 25% in highest priority the next year, and perhaps 10% in the third year, and then we will meet the 5% in the fourth year of our efforts. That's why you can also specify your internal targets. So for people who prefer the EEMUA graph, which gives you in one view the view on how your alarm system is performing, you notice that you have blue dots and you have red dots. The blue dots indicate how your alarm system is performing in steady state under normal conditions. And the red dots, they define how your alarm system is doing in upset states, where you have floods. Well, actually, for this alarm system, the steady state is already an overload condition, and the upset states are outside any of the targets of EEMUA. Right. I think last year, ProcessVue for AVEVA was introduced. What is it? It's the ProcessVue Alarm Management Suite designed and optimized to be used with AVEVA industrial software. So what is it really providing is a special revision of ProcessVue in which parsing of alarm and event data from the system platform historian is already done, which means less integration work, faster up and running, and having a alarm system monitoring and assessment tool available is a step in the digitalization efforts of AVEVA, because it gives you a view on asset performance. It will help you to improve your operations and engineering because it has this information available here. So how does this work with the AVEVA products? Well, you have collectors that are configured for AVEVA system platform, for AVEVA InTouch HMI, for PI system, for AVEVA Plan SCADA, and even third-party products or of other software products that generate events and alarms that you want to collect. All these alarm and events go into a ProcessVue for AVEVA archiver, which is used by the ProcessVue for AVEVA database and ProcessVue for AVEVA analyzer to do the reporting and distribute the reports on one hand side automatically, but also serves as the web server, and you have web clients that you can integrate in your OMI if you like. Now we have talked about OE, and what are alarm management practitioners achieving? Well, in the oil and gas industry, it was and is very common to apply alarm management software to increase the overall efficiency and effectiveness. Actually, I was involved in one of the bigger refineries in the Netherlands, where they had problems with their OE. And basically, by starting to monitor in detail the alarms of that equipment, they noticed that the alarm limits were often moved by the operators. Probably because at that time they had no shelving function, and enunciating those alarms was annoying. But they moved it very often behind the point where the safety system or safety function would kick in, and consequently the FCCU, the fluidized catalytic cracker unit, was shut down. By monitoring the system, of course, the operators were not so eager to move alarm limits anymore, and by removing the fleeting and chattering alarms from the FCCU, they solved the problem, and the OE was doubled for that unit. So, but it can, can come from different angles. I know a chemical plant in Belgium who was doing alarm rationalization effort because the CFO insisted on it. Then the CFO didn't want to pay higher insurance premiums because the insurance company asked for reports on the performance of the alarm system as part of the risk assessment. So they had to show, and they still need to show every year, how their alarm system is performing. More use cases in the food and beverage. Actually, I have a couple of experience in food and beverage. I was once asked to analyze the alarms of a major soy milk producing facility in Belgium. And as a result, I will never drink soy milk anymore. But on another occasion, I heard from a dairy plant where the system integrator was called to the plant because there's 10 centimeters of milk in the storage facility because somebody missed an alarm. In this case, it's a brewery who wanted to reduce the cost. The overall automation strategy of the brewery is to reduce human interventions. To their knowledge, human interventions usually cause more problem than automated interventions or even automated partly shutdowns. I don't know if it's because the beer they drink during operations, but anyway. After they got down to just a few alarms per week in night and weekend shifts, the plant management decided to cash on the effort, and they reduced the number of full-time employees from 21 to 5 per console. And they did this console per console, and they have 4 consoles. That's a big money saving thing. An example of utilities, plant management wanted to reduce unnecessary field trips. Field engineers were sent to remote installations to find out that it was a false alarm, and by filtering out these false alarms, the number of times field engineers had to go out was reduced drastically, which was not only good for the OE, but also good for the field engineers who were less stressed and had more confidence of the trips they made to remote installations. In general, it is estimated that a properly engineered and adequate alarm system can improve 3 to 5% of the overall efficiency and effectiveness of the plant, because it gives you a tool to find when things went wrong, or where things went wrong, or where things were likely to go wrong. Conclusion of me: you need dedicated software to comply with the standards. Whether or not you need to comply with the standards depends on what industry your customer is in, what regulating authorities are in the field of your customer, or what insurance companies specify as risk assessment for your customers. But for any industry, alarm system KPIs will inform plant management, your customer, how well or how bad his plant is, or his production facility, or his infrastructure is performing, which is efficiency and effectiveness. And it will inform plant management where and with what urgency to fix the problem to improve the OE. Mind you, alarm system performance KPIs on their own will not improve the alarm system nor the OE. You will still need engineering work, additional alarm logic, and so on to improve the alarm system in order that it will meet the objectives of the customer. But with a monitoring and assessment tool running, your customers will know if and how much they have improved. I thank you for your attention, and I can get over some of the questions. Let me see here. Kevin Mackey asks if there are any plans to interface with AVEVA Enterprise SCADA. I will refer to that question to the product manager, James Fox, whose email address is here. Please ask. Klebs Hevelin asks, is there any experience of ProcessVue in cloud with application of projects? I guess we have run the ProcessVue for AVEVA in the cloud, so that's also possible. Alarms and event from AVEVA Edge. I don't think it's a problem. Like I mentioned in the slide on catching third-party products, that's possible. And what ProcessVue very nicely is to you can change the layout of your alarm manage to meet other alarms and events you capture. So you have a standardized format of all alarms and events in your plant with multiple alarm and event generators. So you can also do a sequence of event analysis and so on. Okay, has anybody any other question? You can eventually raise your hand. Okay, I don't see any hands raised. Dirk, I turn to you.
Yep. Any other questions, chat, or just unmute and ask? No, going once.
Okay.
Okay. Thank you so much, Lieven. Appreciate your time.
Thank you so much, Dirk, for hosting this tech talk.
Yep. Yep. We got one more question here from Gleb.
Okay.
Yeah, I've got a question about AI, because at the beginning of this webinar, you mentioned about AI, and I'm just wondering if there are some functions that are implemented based on neural networks, regressions, or other algorithms or mechanisms. Thank you.
No, currently in ProcessVue, there are no neural networks or regression calculations integrated, but there are algorithms in ProcessVue that help you to fix problems in your alarm system. Well, this discussion is on AI, what you understand under AI, of course. But no, currently there is no such thing as neural networks or regression calculations performed in ProcessVue. But these things are on the roadmap, and we are interested to see how things are evolving. Also in the alarm management standardization as well, because one of the things that you can see as learning is that the parameterization of the ProcessVue software could be adjusted automatically if somebody changes something in their alarm philosophy. And in working group 9 of ISA 18.2, we are discussing the interoperability of alarm management information to go between work process. And that's certainly something that is of importance, that you can pass that information between the work processes that alarm management entails and the other software tools that are around this. So certainly it's something we are looking into. We're waiting for kind of standardization, because it's standardized, and it can be automatically accessed by other software projects, which is also a way of learning and of AI. I hope this answers your question.
Yes. Thank you very much.
Any other question? Okay, Dirk, thank you so much.
Okay, thank you, Lieven. This will be on HighSpot afterwards. If people want to refer others to it, we'll send an email out. And yeah, thanks again, Lieven. Have a good day.
You're welcome. Thank you. Bye-bye.
Okay, see you.